Alright, so I want to introduce you to integrating some polynomials. Last year you learnt a rule which was that if I integrated ax to the n dx, I ended up going to ax to the n plus 1 over n plus 1 plus c. Okay. Now what that meant was that basically we increased the power by 1 and divided by that power, and we always remember to have plus c. Okay, so that's what we want to do for these first few. If I have x squared, I increase the power by 1, I get x cubed, and divide by that power, I get x cubed divided by 3. Increase the power by 1, I become to x, 3x becomes 3x squared, divide by that power, divide by 2. 1, I increase the power by 1, well, x to the power of 0 goes to x, divide by the power of 1, I get 0. So I get 1 and plus c. Okay, so the logic is there. Again, I've just raised the power by 1 and I've divided through by it. Same with this next one, it's x squared. If I divided 2x squared divided by 2, it's the same as timesing by 2 dividing by 2, so those disappear. And we can just leave it as x squared. The next step, however, this one here, we actually need to start thinking about. So I'm going to take you back a step and rewrite this as the integral of 2x plus 7x to the negative 2. And that'll sort this whole problem out. If we consider this 7x to the negative 2, I can integrate that first term the same. And I increase the power by 1, negative 2 increased by 1 becomes negative 1. And I divide by the power, dividing by negative 1 plus c. Now we'll tidy that up a little bit. That negative 1, well, we won't actually leave it there. We'll just put it as a negative there. Alright, so that sorts that problem out. So we can use that most of the time. The other problem that you do run into, so that's exactly the same there, is when you've got a square root or a power under a square root or some kind of root like that. We've got to remember that we can write roots as fractional powers. So square root is a half. Down here, x squared cube rooted is x to the power of 2 over 3. Okay, so we can do that. So if I integrate this top one, I'm integrating, I could say, I increase the power by 1. Increasing the power by 1 brings me to negative 2. Dividing through by negative 2, I get just a negative sitting in front. Here I increase the power by 1, I become x to the power of 3 over 2. And I would divide by 2 over 3. However, most of us would prefer to write dividing by 2 over 3 as the same as timesing by, dividing by 3 over 2 is the same as timesing by 2 over 3. Okay, plus c. Alright, and you could tidy up that other one if you wanted and make that negative 1 over x squared. Your call. This next one, I've got to change the integral into x to the power of negative 4 over 3 dx. And what that's going to do is, same deal, we're just going to increase the power by 1, so it becomes 5 over 3. Divide by the power, which is the same as timesing by 3 over 5. And then increase the power by 1, that becomes negative a third. Divide by negative a third, that's the same as timesing by negative 3 plus c.